Can you see me right now? Can you see me?
Yes, sir.
Okay, so let us start our today's class. Okay, so today our topic of discussion is relative density and its measurement by Archimedes principle. Okay, so are you ready to start, everybody?
Yes, sir.
Okay. Today your energy level is so low. Why? Why you are so low today? So, first our motivational quotes. There is no elevator to success. You have to take the stairs. That means elevator means generally we call it lift. Lift means a straight shortcut actually. So what does it mean actually? এর মানে হচ্ছে সাকসেস পেতে গেলে না কোনো শর্টকাট নেই। আমাকে যদি কিছু সাকসেস পেতে হয় তাহলে সিঁড়ি দিয়ে উঠতে হবে। দ্যাট মিন্স কি আমরা ভাবি যে হয়তো অনেক সময় এই বইটা কিনে নেবো বা এই কোচিংয়ে চলে যাব বা এইটা করে নেবো ওটা করে নেবো তাহলে একদম ডিরেক্ট জিরো টু হিরো হয়ে যাব, বাট ইট ইজ নট পসিবল। আমাকে যদি সাকসেস পেতে হয় তাহলে কী করতে হবে? স্টেপ বাই স্টেপ উপরে উঠতে হবে। সো অলওয়েজ রিমেম্বার, work hard, work on it to get the success. Nobody can make you reach over there without your effort. Okay, so কেমন লাগলো আজকে মোটিভেশন কোর্স? কি রে,
ভালো,
কোথায়
স্যার।
কোথায় গেলি সবাই, কোথায় গেলি? এত 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 কম পার্টিসিপেন্টস কেন? কোনো এন্থু নেই তোদের? কি চুপচাপ কেন সবাই আজকে এত? হোয়াট হ্যাপেন?
স্যার ভালো লেগেছে।
হোয়াট হ্যাপেন সবাই এত চুপচাপ কেন আজকে? কোনো কথা বলছে না কেউ?
স্যার আজকের মোটিভেশনটা ভালো লেগেছে।
আচ্ছা ঠিক আছে, চলো নেক্সট। আজকে আমাদের টপিক অফ ডিসকাশন কী ছিল? রিলেটিভ ডেন্সিটি অ্যান্ড ইটস মেজারমেন্ট বাই আর্কিমিডিস প্রিন্সিপাল। সো আমরা এখানে কী করবো? আজকে যে টপিক অফ ডিসকাশন মেনলি রিলেটিভ ডেন্সিটি। উই আর গোইং টু ডিল উইথ রিলেটিভ ডেন্সিটি and we are going to measure the relative density by applying Archimedes principle. That is the today's concept. So first thing first, so let us talk about density first. So this is our topic of discussion today. We'll discuss about density, then relative density, then we will measure the relative density by Archimedes principle. So this is the today's class, the entire selection of today's class, and then after that we'll do some numericals. So first, if I ask you which one is heavier, 1 kg of iron or 1 kg of cotton, what is the answer? Anyone? Debaroti, can you hear me?
Yes, sir.
Yes, tell me the answer. Which one is heavier?
Sir, 1 kg iron.
1 kg of iron is heavier. Okay,
Yes, sir.
let me ask you. Yes,
Both will be same.
it will be same. Both are same. Why? That is because it is 1 kg. So if mass is given, then both of the mass is 1 kg. So no matter what is iron and what is cotton, if mass is 1 kg, then its weight will be also same. So both are same. But what is the difference between iron and cotton? Why she replied it is iron, not cotton? Because the density of iron is way heavier than cotton. So let us discuss about density. So what is density? Density can be defined as the density of a substance is the mass per unit volume. We all know that is why density of a substance is equal to mass of the substance by volume of the substance. Is that clear to everyone?
Yes,
I think
sir.
there should not be any confusion. Now what will be the unit of density? Unit of density, basically there are different kind of way we represent the density. Now in SI system the unit is kg per meter square. Okay, in SI system it is kg per meter cube, and in CGS it is gram per centimeter cube. So in CGS density, unit of density equal to, what will happen? 1 gram that is the unit of mass by 1 centimeter cube. Okay, now we want to, that is why we can write 1 gram centimeter cube. That is what we can write. Now we want to figure out what should be the relation between kg per meter cube with gram per centimeter cube. So we will write 1 kg and here we will write 1 meter cube. So 1 kg equal to 1000 gram and 1 meter cube equal to 1000 centimeter cube. Now what we can write, that is why we can write that 1 by 1000 gram per centimeter cube. So the relation become 1 kg per meter cube equal to 10 to the power minus 3 gram per centimeter cube. Is the relation is clear? So if whenever we want to convert 1 gram so whenever we want to convert 1 kg per meter cube to 1 gram per centimeter cube, we will divide it by 1000. Is that clear? Is that clear?
Yes, sir.
So if I ask you which one is the bigger unit, which one is the bigger unit of density, is that kg per meter cube or gram per centimeter cube? Which one is the bigger unit?
kg per meter cube.
kg per meter cube.
Kg per meter cube. Are you sure? Are you sure? See, 1 gram
Yes.
per centimeter cube equal to 1000 kg per meter cube. Okay. Suppose let me tell you. Let me explain you this. This is Ram. This is Sham. So Sham, whatever do Sham multiplies 1000 equal to Ram. So that means which one is bigger, this one or this one? Kg per meter cube is bigger or gram per centimeter cube is bigger? দেখ 1 গ্রাম পার সেন্টিমিটার কিউব যদি আমি নিই সেটাকে 1000 দিয়ে মাল্টিপ্লাই করতে হয় তবে আমি গিয়ে 1 গ্রাম পার সেন্টিমিটার কিউব পাবো। বুঝতে পারছিস না? 1 কেজি পার মিটার কিউব, সি 1 কেজি পার মিটার কিউব যেটা আছে সেটাকে 1000 দিয়ে মাল্টিপ্লাই করার পরে আমি যেটা পাচ্ছি সেটা হচ্ছে 1 গ্রাম পার সেন্টিমিটার কিউব। সো হুইচ ওয়ান ইজ বিগার?
Gram per
Gram
centimeter.
per centimeter cube.
Gram per centimeter
Gram per
cube.
centimeter.
Gram per centimeter cube is bigger, not kg per meter cube. kg per meter cube কে 1000 দিয়ে মাল্টিপ্লাই করার পর আমি গ্রাম পার সেন্টিমিটার কিউব পাচ্ছি, তাহলে কে বিগার? অবশ্যই গ্রাম পার সেন্টিমিটার কিউব। বোঝা গেছে? লাইক আমরা যদি বলি 1 কিলোমিটার অ্যান্ড 1 মিটার, 1 মিটারকে 1000 দিয়ে মাল্টিপ্লাই করার পর যেটা পাবো দ্যাট ইজ 1 কিলোমিটার। So that is why 1 meter is smaller, 1 kilometer is bigger. So that is why here 1 gram per centimeter cube is bigger. I think this is clear. Misconception chilo. Next,
Yes.
effect of the temperature on density. Now see what happen whenever we increase the temperature in any substance like solid, liquid, gas, there is an expansion and this expansion is called which expansion? Due to temperature, due to increase in the temperature, substance generally increases volume. So this expansion has a name. What is the name of the expansion?
Thermal expansion.
Thermal expansion. So this is called thermal expansion. Now due to thermal expansion, now do you know which are the substance where I can get to see thermal expansion? Solid, liquid, gas. For any substance I can get to see there is a thermal expansion, no matter what type of substance it is. Solid, liquid, gas. For solid, thermal expansion is less. For liquid, thermal expansion is greater. For gaseous substance, it has a huge thermal expansion. Hello? 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 Hello, can you hear me? Hello, can you hear me?
Yes, sir.
Yes,
Yes,
what
sir.
is my question? My question is whether it will increase or decrease. The density will increase or decrease. The density will increase or decrease. Tell your answer. The density will increase or decrease. Why you are keeping silence?
So please repeat the question once.
My question is due to the thermal expansion. Due to thermal expansion, the volume increases. Okay? When the temperature is is increasing, the volume increases. Okay, this phenomena is called thermal expansion. Due to thermal expansion, the density will increase or decrease?
Decrease.
Decrease. So
Decrease.
decrease. So what I can say,
Decrease.
density of most of the substance decreases with the increase in the temperature and increases with the decrease in the temperature. So there is an inverse relation. So if I try to find out a graphical representation, I'll find out a graph like this. This is for oil. Okay, this is for oil. Now, now relative density. Relative density. What is relative density? The relative density Rd of a substance is the ratio of the density of the substance by density of the substance that relative density. The relative density Rd of a substance is the ratio of the density of the substance to the density of the water at 4 degree Celsius. Okay. So what I can comment about that, relative density Rd equal to density of the substance rho s by density of the water at 4 degree Celsius. So that means what I am doing, I am just comparing two densities, the density of water with the density of density of the substance with the density of water. So what I can tell, mass of unit volume of the substance by mass of unit volume of water at 4 degrees Celsius. So what I can tell, mass of a certain mass of the certain volume of the substance by mass of the equal volume of the water. So let me just explain you this. I have a substance and I have water. Same volume. Okay, this volume is V, this volume is V, this volume is also V. Now what is the temperature of this water? So this is water, H2O. Now what is the density temperature of the water? The temperature of the water T equal to 4 degrees Celsius. Now what I am doing, sorry, what happened?
Cold temperature.
Yes. Now what I am doing, now I am comparing the mass. The mass is M substance, at this mass is M W. So if I just find out a ratio of them, what I'll get, so just see density of the substance, so Ms by V. So here also I can get density of the water, so Mw by V. So if I just cancel them, I can easily cancel them. So V cancel. So what I can write? I can write that this is equal to Ms by Mw. Okay. So this is what we can write. Is that clear? The relative density, concept of relative density?
Yes.
Yes, sir.
Yes, sir.
Okay. So now my question is, can I write that relative density of a substance? Can I write that like this? If relative density equal to this, what will be the unit of Rd? What should be the unit? Who can tell me the answer? What should be the unit of Rd?
The relative density has no unit.
No unit.
Yes. So whatever be the relative terms have no unit. So it is a physical quantity, but it do not have any unit. So this is an example. If anyone asks you, give me an example of physical quantity which do not have any unit. Example is relative density. Okay. Next, there can be alternative definition according to the mass. As I said, we can compare the mass also. So this should be the alternative definition. Relative density of a substance is defined as the ratio of the mass of the substance of a substance of a certain volume of a substance to the mass of the equal volume water at 4 degrees Celsius. So we are just comparing the mass. The volume should be same and we are calculating the ratio of the masses at when water is at 4 degrees Celsius. Is there any doubt? Clear?
No, sir.
Next, relative density.
Yes, sir.
Now we want to find out
Yes, sir.
relationship between density and relative density. Density and relative density. Relationship between density and relative density. What is relative density? Relative density meaning density of a substance in substance, that is in gram per centimeter cube, and density of water. Density of water. Now what is the density of water at 4 degrees Celsius? Generally at 4 degrees Celsius, the density of H2O, we will not write water, we will write H2O, that is the style, okay? We will not density of H2O is kata 1.0 gram per centimeter cube, okay? 1 gram per centimeter cube. So we'll just put the value over here, okay? And now if we want to do it for SI system, what will be the answer? Density of the substance in kilogram per meter cube. Now as I said, gram per centimeter cube is 1000 times bigger than kg per meter cube. So we'll write at 4 degrees Celsius, the density of H2O is what will be 1000 kg per meter cube. Is that clear? So we'll just put the value over here, okay? Density, the value of the densities, we'll put the value over here, okay? Value of the densities, we'll put the value. Density of water at 4 degrees Celsius, we know the value. The value is 1 for CGS and 1000 per kg per meter cube. So we'll putting the value, we are getting this relation. Is that clear? Clear?
Yes, sir.
Okay. Now difference between the density and relative density. We want to find out a difference. First difference: density of a substance is the mass per unit volume of the substance. Mass per unit volume of the substance. Now relative density. What will be the relative density? The relative density of a substance is the ratio of the density that the substance to the density of the water at 4 degrees Celsius. Okay. Now density of the substance per unit volume that the substance is equal to the, now it is basically the density. We are just writing the definition over here. The first difference you can write the definition. We'll first define, so write definition. Next difference we can write with unit. So this next point with unit, it is to remember, okay? Don't remember the entire difference, just write the definition. First difference will be definition, next difference will be unit. Just remember it like this, you can remember it very well. So relative density do not have any unit and density have a unit, that is gram per centimeter cube. Okay, is that clear everyone? Clear to everyone? Next slide.
Yes, sir.
Okay, now
Sir.
now relative density. Relative density, what is relative density? As I said, mass of the body by mass of the water displaced by the body. Now this point is clear to you or not? This point is clear to you or not? See this situation. If I take a substance inside water, okay, so this is a container and I am taking water on it, okay, this is water. Now now I am taking a substance which is inside the water. So this is a substance which is inside the water, okay. Now can you tell me what is the volume of the water? Volume of the substance? It is suppose V. Now what is the portion, what is the volume of the substance it has displaced? What is the volume of the liquid it has displaced? If the volume of the substance is V, then it has displaced V amount only. এর সাবস্টেন্সটাকে একটা জিনিসে ডুবিয়ে দেওয়া হয়েছে, ভালো করে ভাবো, সাবস্টেন্সটাকে একটা জিনিসে ডুবিয়ে দেওয়া হয়েছে। তো সাবস্টেন্সের ভলিউম যদি ভি হয়, ও তো ভি পরিমাণ, ভি অ্যামাউন্ট অফ ওয়াটারকে ডিসপ্লেস করে তো জলের মধ্যে ঢুকবে, তাই না? ওকে যদি নিজেকে জলের মধ্যে যেতে হয়, ওর ভলিউম যদি ভি হয়, ও তো ভি অ্যামাউন্ট অফ ওয়াটারকে ডিসপ্লেস করে জলের মধ্যে ঢুকেছে। সো what is the amount of, what is the volume of water displaced by the body? What is the volume? V. So definition was mass of the body by volume, mass of the solid, and here mass you can see right properly, just a second. So what you can write, mass of the body by volume, and here mass of the liquid by, or water, liquid or water, let us suppose write water by volume. So volume will cancel or not, because the volumes are same, isn't it?
Yes, sir.
So we can write mass of the body by mass of the water displaced by the body. So what is mw over here? Here mw is the mass of the water displaced by the body. Okay, so তার মানে কি বোঝাচ্ছে যে এই গ্রিন যে এরিয়াটার মধ্যে কে থাকার কথা ছিল? এই গ্রিন এরিয়াটার মধ্যে অ্যাকচুয়ালি থাকার কথা ছিল ওয়াটারকে, এই গ্রিন এরিয়াটার মধ্যে থাকার কথা ছিল ওয়াটারকে। সো এখানে এখন কে চলে এসেছে? সাবস্টেন্সে চলে এসেছে। তো এই সাবস্টেন্সের যা মাস আর এই ব্লু যে পোর্শনটা, এই পোর্শনের ওয়াটারের যা মাস, এই দুটোকে আমি কি করব? কম্পেয়ার করার চেষ্টা করব। দ্যাট ইজ ওয়াই মাস অফ দ্য বডি বাই মাস অফ দ্য ওয়াটার ডিসপ্লেসড বাই দ্য বডি, উই আর জাস্ট ক্যালকুলেটিং দিস। ইজ দ্যাট ক্লিয়ার? নেক্সট, if we just multiply with g, we can write weight of the body by weight of the water displaced by the body. This is what we can write. Next, weight of the water displaced by the body equal to, actually if we just write this weight of the body and now weight of the water displaced by the body, these have a definite relation, that is equal to lose in the weight of the body in water or upthrust. Generally weight of the body displaced by weight of the water displaced by the body equal to the upthrust, তাই না? আপথ্রাস্ট কেন আসে? ওয়েট অফ দ্য লিকুইডের জন্যই আসে। তো সেই জন্য আমি ক্যালকুলেট করতে পারি ওয়েট অফ দ্য বডি বাই আপথ্রাস্ট ইকুয়াল টু দ্য রিলেটিভ ডেন্সিটি। সো দিস ইজ দ্য বেসিক মেথড টু ফাইন্ড আউট দ্য রিলেটিভ ডেন্সিটি। প্লিজ রিমেম্বার, রিলেটিভ ডেন্সিটি ইকুয়াল টু ওয়েট অফ দ্য বডি বাই আপথ্রাস্ট, রিলেটিভ ডেন্সিটি ইকুয়াল টু ওয়েট অফ দ্য বডি বাই আপথ্রাস্ট। ওকে, ইজ দ্যাট ক্লিয়ার?
Yes, sir.
Okay, weight of the body
Yes,
means, sorry, relative density means weight of the body by upthrust. You just need two things. If I tell you what is the relative density, you will ask me two things. What is the weight of the body, sir? I'll tell this is the weight of the body. What is the upthrust, sir? This is the upthrust. So you'll just find out the ratio and tell me this is the relative density. That is so simple. Okay, is that clear? Now upthrust equal to upthrust, if you remember, upthrust it is in the upward direction, that is represented by fb. Okay, so fb equal to actual weight w minus apparent weight. That means weight of the body by weight of the body in water. Okay, if we just find out if we just subtract them, so generally apparent weight, if you remember the equation, apparent weight equal to real weight minus upthrust. If you remember the relation in the last class you have understood that apparent weight of the body equal to actual weight minus upthrust. This is the relation. So similarly we can write fb, if we want to calculate the upthrust, that is equal to the actual weight of the body minus apparent weight of the body in water. We are just finding out the difference between them. So if we just try to find out a ratio, then w1 is the weight of the body in air. So this is w1, this is the weight of the body, in air. So this is also the same. Okay, and what is f2? So what is w2? Weight of the body in water. Okay, So if we just find out this relation, we can find out the relative density. Is that clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Today you're not talking very much. I do not know why. You are so much silence. Students are so much silence that I cannot understand whether you can understand or not. If you tell you understand, tell you understand. If you don't understand, tell you don't understand. But if you keep silence, then it is difficult for me to figure out that. Aditya, thumbs up. Okay, thank you. Okay, now, yes, at least give thumbs up. Then I can understand. Okay, now this is the way by which I can find out the apparent weight. Now, in order to understand what is the weight of the body in air, how can we find out the weight of the body? By using any spring balance or beam balance, I can find out the weight of the body. Now, if I want to find out the weight of the body in H2O, I have to find out this one, W2. Someone asked me, sir, what is the value of relative density of this substance? আমাকে এই রিলেটিভ এই সাবস্টেন্সটা, সাপোজ একটা সাবস্টেন্স আছে আমার হাতে, এই সাবস্টেন্স আছে ধর, এই সাবস্টেন্সের রিলেটিভ ডেন্সিটি বার করে দিতে হবে। What I have to do? I have to find out the weight of the body in a certain balance, a spring balance or whatever it is. You do know how to calculate this, you are familiar with this. So W1 calculation very easy. Now how we can find out the W2? That means I have to find out the weight of the body when it is immersed in water. So in order to do this, what I have done, this is a balance, beam balance, this is a hanging condition. Now generally we find out the weight of the substance like this. Now what we have done over here, we have taken a wooden bridge, and in the wooden bridge I have taken one beaker. Okay, now in the beaker I have placed water and put the substance inside water. So inside the water, very easy, I have put the wooden bridge and find out, I have put it, make an arrangement like this. Now if I find out the weight of the substance, this weight will be W1 or W2. If I find out the weight of the substance in this condition, what will be the weight, W1 or W2? W1 or W2? W2 only. W2, that means weight of the body in H2O. Okay, so if I have done this, then I can write down this relation: relative density of solid, denser water and soluble in it. Now what is the problem? Problem is, if I want to find out substance density, relative density of a substance, what I have to do? আমাকে জিনিসটা জলের মধ্যে ডোবাতে হবে, আমাকে এই জিনিসটা জলের মধ্যে ডোবাতে হবে, তাই না? আমাকে এই জিনিসটা রিলেটিভ ডেন্সিটি ক্যালকুলেট করতে আমাকে কি করতে হবে? এই জিনিসটাকে জলের মধ্যে ডোবাতে হবে। এবার বলা হলো এমন একটা সাবস্টেন্স আমাকে দেওয়া হয়েছে, যেই সাবস্টেন্সটা জলের মধ্যে ডোবালে আইদার রিয়াকশন করে অথবা সলিউবল হয়ে যায় অথবা জলের মধ্যে ডুববেই না, জিনিসটা এতটাই হালকা যে জলের মধ্যে ডুববেই না। দেয়ার ক্যান বি থ্রি কন্ডিশন, আইদার I cannot take it inside water, or I can, if I take it inside water, like it will react like sodium Na. If I take sodium inside water, there will be blast actually. So I cannot take sodium inside water. Next, suppose it is soluble, like sugar candy, it is soluble, so I cannot find out this relative density of this substance like this way. If it is a stone, then I can do this very easily, but for sugar candy, but for sodium I cannot do this. But sodium can be taken inside oil. So what happen if someone asks me find out the relative density of sodium? What I'll do, I will find out the relative density of the liquid first. That is very easy. Okay, we'll just
Sir, the timer has started.
Timer has started. Okay, just a second, I'll finish it up.
So will we join again?
You'll be joining again. What is the time? I have another class
9:45.
also.
Sir, 8 minutes left.
8 minutes left. Let us see how much we can discuss. Now if a solid is soluble in water, insert the solid in, these are the condition. Now what I'll do, relative density equal to the weight of the solid in air by loose in weight of the solid in that very specific liquid. So this concept is same, this formula is same. Now what I'll do, I will just find out the relative density of the liquid and we'll multiply them basically. Okay, so separately we'll find out the relative density of the liquid and we'll find out the relative density of the substance with respect to that liquid. Okay, so এখানে তার মানে আমরা কি করছি, দেখ আমাকে বলা হলো আমাকে বলা হলো যে সাপোজ একটা এক্সাম্পল দিয়ে বলছি যে এখানে রাম আছে, এখানে সাম আছে অ্যান্ড এখানে কামাল আছে। ওকে, কামাল আছে। নাও আই ক্যান নট কম্পেয়ার রাম অ্যান্ড সাম, রাম অ্যান্ড কামাল। রাম হচ্ছে এখানে ওয়াটার, সো আমাকে রামকে কামালের রেসপেক্টে কতটা লম্বা সেটা ক্যালকুলেট করতে বলা আছে। সো হোয়াট আইল ডু, আইল জাস্ট ফার্স্ট কম্পেয়ার সাম অ্যান্ড কামাল। আই কম্পেয়ার সাম অ্যান্ড কামাল লাইক দিস। সামের থেকে কামাল কতটা লম্বা ক্যালকুলেট করলাম, তারপর রামের থেকে সাম কতটা লম্বা সেটা ক্যালকুলেট করলাম। So if I just compare them and add them, what I'll get? I'll get the total difference between them. Similarly, what I'm doing over here, I'm finding out the relative density of the liquid first and then finding out the relative density of the solid with respect to that very specific liquid. So that will be the answer. Is that clear? Is that clear?
Yes, sir.
Okay.
Yes, sir.
Okay, now relative density equal to weight of a given volume in the liquid by weight of some weight of the same volume in the water. Okay, that is the concept যে রিলেটিভ ডেন্সিটি কোন একটা সাবস্টেন্সের স্পেসিফিক ক্যালকুলেট করতে বলা হয় একটা গিভেন লিকুইডের জন্য। রিলেটিভ ডেন্সিটি অফ গিভেন লিকুইড কী করতে হবে, এবার লিকুইডের ক্ষেত্রে কী করে ক্যালকুলেট করতে হবে, লিকুইডের ক্ষেত্রে কী করে ক্যালকুলেট করবো, কারণ আমি তো বলে দিলাম যে কোন একটা ভেরি স্পেসিফিক লিকুইডের রেসপেক্টে ক্যালকুলেট করুন। তো হোয়াট ইজ দ্য ওয়েট অফ আ গিভেন ভলিউম ইন এ লিকুইড অ্যান্ড ওয়েট অফ দ্য সেম ভলিউম ইন ওয়াটার। ফার্স্ট আমি একটা বিকার নিলাম, আই এম টেকিং অয়েল, সেম বিকার নিলাম, আই এম টেকিং ওয়াটার। So this is oil, this is water. If we just compare their weight, what I'll get? I'll get the density of the, relative density of the solid, relative density of the oil, isn't it? আমি যদি এখানে কি, আমি যদি একটা জায়গায় ওয়াটার নিলাম, একটা জায়গায় অয়েল নিলাম, সো অয়েলের ওয়াটারের যদি মাস কম্পেয়ার করি তাদের ভলিউম তো সেম। রিলেটিভ ডেন্সিটি মানে কি বলেছিল, রিলেটিভ ডেন্সিটি মানে কি বলা ছিল, রিলেটিভ ডেন্সিটি মানে বলা ছিল যে mass of the substance by mass of the volume by mass of the water by volume. So same volumes are same, so volume will cancel, so mass of the substance, so mass of the substance এখানে কি হবে, অয়েলের মাস ক্যালকুলেট করব, by mass of the water এখানে কি হবে, ওয়াটারের মাস ক্যালকুলেট করব। if we just find out the ratio between them, what I'll get, I'll find out the relative density of the liquid. So in a final note, what I can write, the relative density equal to the weight of the liquid displaced by the body by weight of the water displaced by the same body. That is why we can write weight of the body in air by weight of the body in the liquid by weight of the body in air by weight of the body in the water. So that is how we can calculate find out the relative density of the substance. Okay, is the concept is clear? We are just find out the difference between ratio between them, weight of the body minus weight of the body in liquid by weight of the body in air by weight of the body in water. So weight of the bodies will be equal, weight of the body in that very specific liquid by weight of the body in air by weight of the body in water. So basically what I can write, W1 is the weight of the body in air, W2 is the weight of the body in the liquid, and W3 is the weight of the body in water. So this is how we can write. Okay, so this is the concept of Archimedes principle. So thus we find out the relative density of a liquid using Archimedes principle. We take a body which is heavier both of the given liquid and water, and also insoluble in both. The body is first weighed in air, then in liquid, and then after that washed and in water and dried. If the weight of the body if the weight of the body is in air is W1, so this is W1. If the weight of the body in the liquid is W2, this is W2. And if the weight of the body in water is W3, this is W3. So we'll just find out the relative density of the liquid by this way. Is that clear?
Yes, sir.
Okay. So there are few questions, and now if this point is not clear to you also, after doing some numericals, this equation will be clear to you after solving some numericals. But I do not know whether I can discuss the numericals. The class is already over because I have to take another class. So do one thing, please do one thing. I am finishing the class of few numericals I have decided to do.
Hello sir.
Yes.
Sir, we have to learn the table of the density and relative density.
That very specific table. You don't
Yes,
have to.
sir.
You don't have to remember. You don't have to remember everything. You don't have to remember. Okay. So this is what we have to learn today. So what we'll do in the next class? We'll do in the next class, like we'll discuss about this questionnaire of these three chapters. The three power portion we have completed. We'll solve some numericals and we'll the exercise portion. Okay. These numericals we'll do actually, but this is we do not have time today. So in the next class we'll discuss the numericals. So is that okay? Is that okay?
Yes, sir.
Okay, so that's all for
Yes,
today.
sir.
That's all for today. So what I want a participation from your side. You are keeping quiet. You are keeping quiet, like you're just not telling anything. I'll just chup ekdam sir porache chup. So I don't want that. I want a participation from your side. I want a participation. হ্যাঁ কথা বলতে হবে, হ্যাঁ না বুঝতে পারলে বলতে হবে. So I want a participation. Okay, is that clear? সবাইকে কিন্তু কথা বলতে ইন্টারঅ্যাক্ট করতে হবে.
Yes,
সবাই চুপ
sir.
থাকলে হবে না. ঠিক আছে? ঠিক আছে?
Okay,
ঠিক
sir.
আছে স্যার।
ওকে চলো বাই টাটা।
Thank you, sir. Tata. Bye bye.
Thank you, sir.
Thank you, sir.